For this video, we are doing more inequalities. I talked about why they are working like an equation and why the sign changes. And then I also showed in the last video the number line graph, kind of what it means on the number line. So now I'm going to show you two things: solving it using the properties I talked about in the last video, so solving it, and then graphing it. So we're going to do two things. So I'm going to solve it. So I'll solve it here first, and then I'm also going to graph it. Okay, so I'm going to do two things for this question: solve and graph. Always read the question. Okay, so the first thing I'm going to do is solve it. In order to solve it, we're going to use this just like we do an equation. So an equation means that we're going to take all of the variable terms with the variable x in it, or whichever variable it is, and bring them to the same side. This works like a barrier. So that works just like an equal sign. So if it's going to hop over the equal sign, you don't have to show the arrow or the circling, but when this hops over the equal sign, it changes the operation. So right now it's a positive 5x, it's going to hop over and become minus 5x. The 3x did not move, so leave 3x where it is. So I wrote that as is, it didn't move. This one moves. It crosses the barrier, see, that's why I draw the arrow, so that becomes minus 5x. Still keep the arrow there, just like this inequality here, just like an equation. The 12 didn't move, so leave the 12 alone. Okay, then we get 3 minus 5x. 3x minus 5x, that's negative 2x, which is less than 12. Okay, so then you go, okay, I'm almost done solving it. So make sure this is treated just like an equation. I want to divide both sides by whatever's in front of the x. So whatever's in front, negative 2, so negative 2. This cancels out to be 1. You want to copy it exactly. So if it's a negative 2, you divide by negative 2. If it's a positive 2, you divide by positive 2. If it's a negative, so you divide by itself. That becomes 1 because the two negatives cancel out. And then you have x is less than, I divided by a negative. So this is the step where I go, now this is the one rule that I said does not work the same way as an equation. When you divide by a negative, so it's this step here, I'm going to star that. When you divide by a negative, this direction needs to change. So see how it's closed to the x? I want it to be open to the x. So I change the direction of the mouth, changes from this to this. So right now it's this way. I want you to switch it so it's that way. So then it's this way. And then you get 12 divided by negative 2, so it's negative 6. So my answer is x is greater than negative 6 because of this line. When you divide by a negative, then you want to switch the direction. Okay, this is your brain thinking that. So I want x to be greater than negative 6. Now, when we graph this, when we graph this, I want to see the number negative 6. Because this is not equal to, it's going to be an open circle on negative 6. And see how the mouth is open to the x? So you're going to read this, x is greater than negative 6. So to the right. Greater than is to the right, less than is to the left. So you just draw an arrow and say it continues that way. Make sure the line is long enough and with a ruler. Okay, we're going to try that again. We've got all these guys here. I see xa's on both sides. I want to bring them to one side. Doesn't matter which side you bring it to. So I'll bring it to the left. So this one, and I'm going to cross the barrier. This works like an equation. That's my barrier. If I bring the a's onto one side, I need to bring the numbers with no letters onto the other side. The only one that moved was this one and this one. So write down negative 2a. It did not move. So exactly as is. This one moves over, so instead of plus a, it's minus a. Leave that in the middle. 9 did not move, so write that exactly. Did not move. 3 hops over, so any one of the ones I've drawn an arrow, those ones change. So that's a positive 3, so it'll be a minus 3. So you're going to get negative 2a minus a, which is negative 3a. Remember, there's an invisible 1 here. Negative 2 minus 1. There's invisible 1. Don't put it there, but you should imagine. Negative 2 minus 1 is negative 3. Greater than or equal to 9 minus 3 is 6. Okay, so imagine there's a 1 here. You don't have to write it, but there's a 1 there. So negative 2 minus 1 is negative 3. 9 minus 3 is 6. Okay, again, don't show that one there. Now, I'm going to divide both sides by negative 3. When you divide by a negative, you want to switch the direction. So this is the step. I'm going to start again. This is the step where you have to switch. Okay, and then when I switch it, that becomes 1, right? So this will be A, which is greater than or equal, sorry, that switches less than or equal. Okay, so this one becomes less than or equal, less than or equal. So this is the switch. I'm going to use a highlighter. Just circle this right here. That's the switch. Okay, so less than or equal to, oh sorry, I divided both sides. Oh, I'm being sloppy. Did you catch my mistake? So divide both sides by negative 3. This becomes a negative 2. And then I want that sign to change direction. So instead of this way, it's now this way. So change direction. It was this way. I divided by a negative 3, so now it's this way. So hopefully you caught my mistake and you went, ooh, I saw that. That's good. Okay. From my mistakes, you can learn as well. Okay, let's draw a number line. So you'll want to see negative 2. It's less than or equal. Equal means solid dot. Okay, because it's equal to here, so it's solid dot. And then you don't have to write that. That's just my brain thinking. So everything I do in bubbles is just my brain. This is negative 2, so label it. And A is close towards A, so less than or equal. So you want to go to the left. Right? If it's open to the A, then that means greater. Close to the A, it's less than. So then you go to the left. Okay, so it's solid dot because it's less than or equal. It's this part that's telling you it's solid. That one. Okay, for this one, let's try it again. So regular solving, just like we did before, the first step we want to do when we see brackets is get rid of those brackets. We're going to go 1, 2, and this positive 2 goes in as well. I'm going to rewrite this. This will be negative 18W. Negative 3 times that. Negative 6 times positive 2 minus 12. Negative 6 times positive 2. Keep the sign in the middle. Oh, you'll notice also, look, see on this side here, no equal signs. So I want no equal signs. I'm going to just write that down here. Okay, so no equal signs on the left side. Look, no equal signs here. No equal signs here. No equal signs on the left side. On left. Nothing here. No left sign, equal sign. Because you already have the inequality in the middle. That works like an equation. That works like an equals. You can't have double. No doubling up of signs. So here, don't put equals on the side. Don't put equals on the side. The inequality in the middle works like an equation. Okay. Then this, the positive 2 gets distributed. The negative 4W stays where it is. 2 of these. So it'll be 16. Positive 2 times that. So negative 12W. A distributive property. All right. Then what we want to do is we want to gather up all the W's onto one side and set it equal to 0. Or not 0, sorry. Set it equal to the numbers. So we've got the W, and the W. So the terms with the W. I have 2 of them on this side, 1 of them here. So I'm just going to move it over to be with its other friend. Okay, then I have 2 numbers with no W, and I want them to be on the opposite side. So I'm going to have to move the W to that side. The only ones I put arrows for are the ones that had to move. When I cross this barrier, they become the opposite. These 2 stayed where they are, so only this one's moving aside. So watch. I wrote the negative 4W here, the minus 12W here. They did not move. This one's moving to this side to be with it. So instead of minus 18W, it's plus 18W. Whoever crossed the barrier. These 2 did not cross it. They stay where they are. Then the negative 12 is also not moving, but the 16 crosses the barrier and becomes minus 16. Then you're going to finish each side, so negative 28, and then negative 4y minus 12 is negative 16, plus 18 is 2w. So now I'm going to divide both sides by whatever's in front of the variable. So this last step, I'm going to divide them both by 2, because that cancels to be 1. Then I get negative 28, and look, because I divided by a negative, it does not switch the direction. The only reason I switch these ones is because I divided by negatives. If I'm dividing by a 2, do not switch the direction. So my answer will be negative 14 is less than w. That's it. Oh, sorry. Yes, negative 14 is less than w. If you read it from the w, w is greater than negative 14. So one more time. You can read it two ways. You either go w is greater, so the mouth is open to the w is greater than negative 14, or you can say negative 14, see how it's closed, is less than w. They both mean the same thing. So when I graph it, I like to put the number first. So I'm going to go, is this without the equals? Not equal to, so open dot. Okay, so negative 14, make sure you label that. And then w, I like to read from the variable. W is bigger. It's getting eaten, bigger than negative 14. So to the right of negative 14. Okay, w is bigger. Okay, now this last question for this example here, for example 1, we are looking at fractions, right? So this works just the same way as we're solving an equation with fractions. So first thing we had to do with this was to get rid of the brackets, and then lowest common denominator, step 1 and 2. So let's try to remember. For the brackets, we had to put, if there's whole numbers mixed up with fractions, I always put them over 1. It's a good habit to do. Then you want to get rid of the brackets. Getting rid of the brackets is distributive property. So I distribute the 3n, I distribute the 3n. For the denominators, you're distributing the 4 into both. Okay, so 3 times 3 would be 9x, 4 times 1 over 4, minus 3 times 5 is 15, 4 times 1 is 4. Then you keep the sign in the middle. Notice, look, no equal signs here, no equal signs on the left, only in the middle. Then you go top times top, so it'll be 8 over 3. Top times top, right, numerator times numerator will be 2x. And then the denominator, 3 times 1, 3. So now they all have a denominator, which is good, but they're not the same. So then this we did the brackets. Now we have to do lowest common. Lowest common will be between 4, 4, 3, and 3, 12. That means this one, if I multiply it by 3 on the top and the bottom, I get 12. This one, if I multiply the bottom, top and bottom, numerator and denominator by 4, I'll also get 12. Okay, so then we get 27x over 12, 45 over 12, 4 times 8, 32 over 12, plus 2x times 4, 8x over 12. Okay, and this works exactly the same way as with an equation. You take this denominator because they're the same, and you can say you're all standing on step 12, so let's forget that, and rewrite just the top. So 27x, 45, 32, 8x. And the pattern for this is the same as with an equation. I look to see who has x's, and I move them to one side. And the reason why I put the arrow there is because it has to cross the barrier. And then I do the same thing here. 45 and 32, I want at the opposite side of wherever the variables are going, so I'm going to move this one, not that one. So then we're going to go. 27x stays where it is, so write that first, did not move. The one with an arrow moves, minus 8x. 45 is moving over. 32 did not move, so leave 32. Positive 45 moves over, so it's minus 45. Okay, if I run out of room, I please want you to do a big sweeping arrow and guide my eyes. So you're going to say over here. So then I want the x's on one side, which I already have. Okay, oh, so we just did that one, so we have that one already. So 27 minus 8 is going to get me 19x. Sorry, I already did that step, so less than or equal. And then this one and this one are like terms, 32 minus 45. So that would be 32. Oh, I lost a sign here. I'm so sorry. So hopefully you caught that. This was still minus. Positive 3 times negative 5 is negative 15. And then, yes, I noticed that as well. Sorry. So if you saw that earlier, we're fixing that now. And then here, this would be 45. Right? So that did not change signs. 3 times negative 5 is negative 15. I should have carried it down here. I still did this lowest common. That's okay. 45 will come over here as plus 45. So we're going to get 19x. Sorry, I already wrote that down. 19x over, so less than or equal, and 32 plus 45 is 77. So if you're catching my mistakes, good. But then I want you to be able to do it yourself with no mistakes. That's the goal. Not just correcting me. Sometimes you can correct me because you're following step by step, but if you can correct yourself, that's even better. That's what we want you to be at. So if I divide both sides by 19, this becomes a 1. And then here, I didn't divide by a negative. Okay, so I leave it that way. Yeah, so it's just less than or equal to 77 over 19. That does not divide in nicely, so we're just going to leave it like that. And I like fractions, right? We heart fractions, and we are just going to answer it this way. So if it's less than or equal, solid dot on 77 over 19. Less than or equal means to the left, less than, and we do this. Okay, so watch out for the signs. When you divide it by 19, I didn't need to switch the signs and leave it as a fraction.